there, in this calculus video we're going to take a look at a limit of a function graphically, and then there will be a follow-up where we start to look at how can we evaluate our limits of a function algebraically by manipulating some of that algebra. So it's first and foremost important that you understand that a limit is very similar to a y value. It is an output. So the limit's going to be as the graph gets closer and closer to a particular output value, but it may not actually equal that number. It's approaching it. Now sometimes it may be equal, so let's take a look at what I mean. So find the limits given by this graph of this function. This is certainly a piecewise, so in order to keep it a function, we had to pass that vertical line test, which means that you may not have two outputs for that same input value. So for example, at x equals 1, the function's defined to be 1, 1. That's why we have a hole at 1, comma, this appears to be maybe, we'll call it 3.8. Okay, so I'm going to label. It is important to note also that when you're looking at a graph and reading a graph, just do the best you can and estimate and round to whatever they say. So let's go ahead and answer these questions. The first question is asking us for limit. This is the limit notation. Limit as x approaches 2. But you see that little plus after the 2? That's going to give us that direction. So because it's a plus, we're going to say as x approaches 2 from the right. If there is no plus or minus, like in the x approaching 1 in question B, then we assume it's both from the left and from the right. If you look at question C, this one says as x approaches 2 from the left, because that minus after the 2 gives us that direction. So I have limit as x approaches 2 from the right for question A of the function. It's important to note that you need to have limit of a function, just like we have square root of something, right? We also have limit of something. So what I'm going to do is I'm going to draw on this graph where x is approaching 2. So I'm going to draw this green line here. And so as x approaches 2 means I'm coming in either from this side or this side. And what's also important to note is not only are you going to look at the x value, but you need to be along a curve. So a limit will always be along a curve. And what I mean by that is it will never be, see how this point 1, 1 is sort of just freestanding here. It's not really a part of any curve. There is no from the left and from the right. It's just that function's value, but there's nothing before it or after it connecting to that point 1, 1. So this point will never be part of my limit answer. A limit must be along a curve. So if I'm asking for a limit as x approaches 2 from the right, I see the green line where x is equaling 2, but now I want to come along my curve. So if I'm doing that, I'm coming along my curve as x approaches 2 from the right. I appear to have a y value or output, even though it's a hole, that's okay, of -1. So I'm going to actually jump down to C next because it's still dealing with as x approaches 2. So now it's saying as x approaches 2 from the left of my function. So I still see that, green line that I put there for x equaling 2, but I'm approaching 2 from the left, so I find where my function is from the left. I'm up here. And so my function looks like it's approaching, I believe we'll call that 3.8. If you think it's 3.7, 3.75, 3.9, there's a tolerance built in. So you're just reading the graph. Okay, so here's the problem though. My limit from the right of this function as x approaches 2 is -1, and my limit from the left as x approaches 2 of the function is 3.8. Those are not the same value, which means the direction's going to change your limit. So as you come in from the left and as you come in from the right, as you're approaching 2, you're coming up to 2 different points. So therefore, If I don't give you a side, like in question D, we just say limit of the function as x approaches 2, this needs to be from both the left and right sides. And since the left gives me 3.8 and the right gives me -1, which one would I say? Well, I would say neither. I would say DNE, which stands for does not exist. And what's important to note is that DNE or does not exist cannot just be one of those default answers of, gosh, I don't know really, so I'll just say DNE. We have to explain why. So I'm going to also say because the limit of my function as x approaches 2 from the left does not equal the limit of my function as x approaches 2 from the right. So the one-sided limits are not equal. A one-sided limit, I hope that makes sense of what that is, means you're coming in to the same value, right? X is approaching 2 in both, but from one side. Okay, so let's go back and answer question B. So I have the limit of my function as x approaches 1, and since there's no side attached to this, I have to come in from all sides, so from the left and from the right. Well, as x approaches 1, again, my function's value is right there at 1, 1, but see how there's no curve for me to like come in on and get to that point? So again, that's like a distractor point. That will never be a limit. That is your function's value. So a true statement would be, my function's value at 1 is 1. Yes, true. But the limit will be along your curve, so you have to be moving. Calculus is all about things moving. So let's take a look at what that means. So x approaches 1. Where's my curve? Well, my curve is up here. So from the left and from the right, so when you're a little bit less than 1, so like if you have an x value of 0.999, or if you have an x value of 1.001 because you're coming in from the right, it appears that you're headed towards that same hole or output value of 3.8. I know it's a hole. This is where we say the limit may not actually equal that number, but you are approaching that number. Okay, so for question E, limit as x approaches 3, again, there's no side, so it needs to be from both sides. So why don't you go ahead and pause the video and see if you can figure out what would be the limit of your function as x approaches 3. Okay, so hopefully you have taken a look at this. As x approaches 3, you're right here. It is included on your function. And so here's from the left, here's from the right, and so my output value is actually 0. Okay, I'm going to add actually one more question here just for some additional practice and some work with infinity. So the limit of my function as x approaches infinity. So let's think about that for a minute. As x approaches infinity, that means you're going out as far as you can to the right. So where is your function going? This is kind of a one-sided limit. You can't really get to infinity from the other side, right? So I'm coming in here from the left, and as x goes to positive infinity, do you see your function is going up? Up where? Well, to positive infinity. Okay, great. So now we're going to do this backwards. Let's draw an example of a function that satisfies all of these given conditions. So I have some limits that I'm given, and then I also have some function values. So I'm going to highlight these in yellow. These are just points that have to be included, but they don't necessarily have to be along a nice, neat, continuous curve. The limits, however, need to be along a curve. So I'm just going to go ahead and put these static points on there. I'm labeling because you can't really see. This says X and this says Y. So there's my axes that are labeled. So my function's value at 1, so I have an input of 1 and I have an output of 1, and that needs to be a closed point. And then also, when my x value or input is 4, the output is -1. So these need to be points on your function, but not necessarily along the curve. So I don't necessarily need to have something coming in and going out of these points. So I have those two on there. So let's look back at our limits. So we have in the first one, limit as x approaches 1. Well, this has to be from both sides. So the limit as x approaches 1 from the left and from the right needs to be 3, which means here's my input of 1 and my output needs to be 3. Well, I cannot put a point up here at 1, 3 because I'm saying that this is a function and that would violate the vertical line test. So instead, I have to put a hole up here at 1, 3. And this is where my curve has to exist because this is my limit. And limits, again, are along curves. Okay, so from the left and then from the right. Now, again, it doesn't say what kind of curve it has to be. That's up for me to draw. So maybe I think that to the left this is a parabola. And maybe I'm not sure yet on the right what this will be. So I'll just kind of start something there. Now, as x approaches 4, I have some sided limits here that I have to work with. So as x approaches 4, this one is from the left, then my output is 3. And again, I can't put a closed point because I've already got that closed point down there at 4, -1. So I'm going to put a hole at 4, 3. And that I have to be able to get there from the left. So I'm going to continue this over until it touches. And now if I'm along my curve or along my function, which I've called f, then as I go from the left and approach an x value of 4, then my output would be 3. So I've satisfied that limit. And then the last limit that I have to satisfy says as you approach 4 from the right, you're going down to -3. So yes, there's a hole at 4, -3, but it needs to be from the right. So maybe writing it out this way helps as well. This previous one was a hole at 4, +3, but from the left. Okay, so let's draw this. I have a hole at 4, -3, and it's from the right. I approach that value. And it doesn't say anything about the function having a restricted domain, so I just put arrows to the left and to the right, signifying that this will go to infinity. So I'm just going to make this a little bit darker, make it a little bit maybe more clear. So, and again, the curvature of it doesn't really matter. Just make it continuous and make sure that you don't violate any function restrictions. So it looks something like so. And I have a hole and some function in between. Again, it could have been a horizontal line. Doesn't have to be too fancy. A hole. And then a hole down here at 4, -3. And a function out. And again, don't forget you have these 2 points on here, 4, -1, and 1, 1. So this is one example of what my function might look like. Again, your curvatures could be different. I'll show you what I mean. I could have something like this, for example. That's fine too. You could have a horizontal line in between these two. Right, well, that's supposed to be a horizontal line. That would work as well. Doesn't have to be too fancy. Hope you found this video on limits graphically helpful, and you will continue to explore these throughout your calculus course. Thanks for watching.